So let's talk a special case of proportion. So proportion means the observation is either 0 or 1. Either you have something or you don't have something. Okay, or maybe gender, you're male or female, or whether you go to school by bus or not. So the mean population mean mu is called pi. So pi sometimes we will call population average. Is pi sometimes called proportion because it's naturally this mean is adding up divided by n is proportion, right? And the variance will be pi times 1 minus pi. That is coming from the polynomial trial. So polynomial trial, right, is mean pi, and then the variance will be pi times 1 minus pi. So the case of sample average, right, is adding up all, right, we'll call the sample proportion, right? There's nothing different but from this formula, but there's a new term p we call sample proportion, but it's a sample mean in the special case. It's nothing new, but the new name called sample proportion because this population is proportion. So that is the idea. So the variance, the formula is the same, right? Which will be the population variance over n. So in this case, it's pi times 1 minus pi over n. The standard error proportion is the same, just square root of the variance, right? So it's the root of the fraction pi times 1 minus pi over n. So and the central limit theorem also applies, right? So will be when n gets large, this p will be approximately normal with this mean is pi and the variance pi times 1 minus pi over n. So that means the z, which is pi p minus pi over the root of pi times 1 minus pi over n, okay, will be normal 0, 1, okay? And in particular, for this to hold, the central minimum theorem would require you the n pi and n times 1 minus pi is at least 5. If not, then you need to use other method, but make sure you check it carefully whether this is true or not. Okay, so let's see an example. So consider population proportion is 0.6, okay? The sample size 100. So the question is asked, what's probability that the sample proportion is less than 0.55? So what you do is first check n pi and n times 1 minus pi is at least 5, okay? So so n is 100, okay? 100 times 0.6, right, is 60, right? 100 times 0.4 is 40, so it's bigger than 5, so it's fine. So central limit theorem applies, and then we do calculate the probability p, right? Sample proportion is less than 0.55. Then we can rewrite it by z, right? So there's 0.55 minus 6, which is sample proportion over pi times 1 minus pi over 100. Then we get a negative 1.02. Then look at the z table. Then you can find the answer. Okay, so that is the end, the sample proportion part.